everyone to the past seminar. And today we're really honored to have Professor Gillian Hatfield here with us. Professor Hatfield is a professor of computer science with a joint appointment in the School of Government and Policy at Johns Hopkins University. Her research is focused on innovative design for legal and regulatory systems for AI and other complex global technologies, computational models of human normative systems, and working with machine learning researchers to build ML systems that understand and respond to human values and norms. So today we're really excited to have Professor Hatfield here to talk about normativity and the AI alignment problem. And without further ado, Gillian, please take it away.
Thanks, Lucy, and thanks for inviting me. I'm really looking forward to this conversation and hope we'll get some good chance for some discussion. Okay, so I am going to be talking about normativity and the AI alignment problem, and sort of pulling together a lot of threads of things that I've been working on for a very long time, some new things. And I also wanted to start with an advertisement, say a number of things that I'm talking about. I'll be talking about with Dylan Hadfield-Manel, Joe Lebo, and Rakshit Trivedi, also at a tutorial we're running at NeurIPS. Tuesday, December 10th. So those of you who are going to be in Vancouver, please feel free to come on by and get a deeper dive into some of these topics. So let's get started. So the core question here is asking, what does it really mean to align an AI? This has gone from kind of a niche area of work to sort of broad-based discussion. And there's a lot of ideas that people have about what it means to align AI. I think the dominant version you'll hear is it's making sure that AI does what its designers intended. And this video from 2016 in a blog post out of OpenAI sort of introduced, I think, just it's a lovely canonical representation. I'm sure most of you have seen it before. Of here's a reinforcement learning system that is not doing what its designers intended. They intended to build something that would be able to play this video game and reasonably enough use the score as reward, but the machine did not learn to actually win the race. That was sort of left out at the design time. So that's not doing what its designers intended. Now, of course, we're thinking about our large language models, and we're thinking about things like, well, we don't actually intend for our language models to help people kill anyone or produce dangerous bioweapons to assist people with criminal activities. So this is from the OpenAI system card from GPT-4. So that's a version of alignment. And then as we start thinking about a world with increasingly agentic AI systems, I have no idea if something like this that Mustafa Suleyman was talking about last year could be as little as another year away. But it's the idea that maybe we're looking at a world with millions, billions, according to Mark Zuckerberg, of AI agents out in the world. And you might think, well, are they doing what their designers intended? Here it would be go make $1 million on a retail web platform. So that's sort of the core idea that people have, but there's a lot of other ideas that people talk about as well. So we've actually been thinking about the idea that alignment could mean programming the machine to produce outputs that comply with rules, since Asimov introduced the ideas of the 3 laws of robotics in the 40s, thinking about how do you make sure those robots are doing what we intend? Well, how do we want to make sure that they're following rules like don't kill humans? Another version of what we can mean by alignment is not to comply with rules, but rather to comply more generally with moral principles, more grounded, but more high abstract. And so there's been, of course, a significant amount of work thinking about the concept of how would you build moral machines, teaching robots right from wrong. Another set of ideas is rather than sort of thinking about programming your machine with moral principles, is to think about how would you train it on data from human moral choices to elicit from observed moral choices what humans consider to be morally correct. So we have this as an example. The Moral Machine project at MIT Media Lab was collecting this data on collective, crowdsourced various questions for, okay, what should the self-driving car do in these various settings? Kill the passengers, kill who's in the crosswalk. How does that vary with who's in the car and who's in the crosswalk? Sort of expanding out, another way of thinking about alignment is to think that what we mean by this is that we give the machine objectives that align with ours. And Stuart Russell has talked about this concept of alignment for a long time, but also in his book Human Compatible, the idea that it should be our objectives that the machines, our AI systems, are responding to. And then there's versions, I think we are seeing increasingly people talk about the idea, well, we don't want it just to be what designers intend or what the users intend, but that what we should be doing is building our machines by giving them the objective aligned with the objectives of what is considered morally right. Could be defined by the individual, but could also be defined by society. I think Brian Christian, in his book, The Alignment Problem, captures sort of the full scope of the ideas about alignment when he says that alignment is ensuring that models capture our norms and values, understand what we mean or intend, and above all, do what we want. But of course, the question we come to, especially as we expand from the idea that it's limited, alignment is limited to doing what designers intend, to the idea we might be talking about selecting values and objectives for society as a whole, is to say, well, whose values matter here and determine how and by whom. So I'm actually currently at a conference on AI and democratic freedoms, talking a lot about, there's lots of discussion and work these days as well, of course, on thinking about how do we determine these values, what would be democratic ways of determining values for alignment. So the point I want to get us focused on, and most of my work is focusing on, is to say, what we're thinking of as the alignment problem for AI is really it's the fundamental problem of human society. And that is, how can we live together? How do we establish, sustain, and grow stable groups? That humans have been tasked with figuring out this problem since there were humans, modern humans. And I think that this is a lens that can help us reframe the way we think about alignment. So if we think about humans solving the problem of alignment in their groups, how do we live together? How do we maintain our groups? And our groups are very valuable because they allow us to benefit from shared defense and mutual aid and care, specialization in the division of labor. So it's the primary task of human societies is to maintain stable groups. And when you look at it through that lens, things like norms and culture are fundamentally alignment mechanisms. So think about small hunter-gatherer bands that establish lots and lots of norms, lots of culture about how we build arrows and how we build huts and who gets to eat and share around the fire and how we take care of our children. Those are alignment mechanisms that coordinate everybody who's in that group on the same set of activities and the same set of rules to produce a stable group. In our modern societies, it's important to recognize that markets are alignment mechanisms. Markets operate through sort of, Adam Smith's famous concept of the invisible hand. The idea that, so if you want to think about that as an alignment mechanism, the invisible hand moving people to make decisions about what they will produce and what they will purchase and how those goods and services will be allocated. And in fact, we have theory in economics, which is my original and primary field, that establishes theorems like our first welfare theorem, which says that perfect markets will maximize social welfare, defined as the sum of individual utilities, by achieving a Pareto optimal allocation of resources and goods. And this is a theorem that tells us that even if we have wholly self-interested individuals who are not interested in anything other than maximizing their own subjective utility, we can nonetheless align them to produce the best outcome for the group, defined in terms of those utilities. And of course, we don't have to say that's the appropriate goal, but nonetheless, here we have a theorem, much like, when we're thinking about physics in a vacuum, right? We know perfect markets don't exist, but it gives us a basis for saying, oh, we can actually get to these socially optimal, according to a certain definition, for the group when we align through the price mechanism. And then we have a second welfare theorem that says, and if we don't like the distribution of goods and services that result in that, the outcome that is produced by those perfect markets, well, we have this theorem that tells us, well, we can get to any final distribution that we prefer by redistributing initial endowments. Again, these are theoretical results that just help us think about what's happening in markets. So I want you to start thinking about these also as alignment mechanisms. Law and politics are alignment mechanisms. There are ways in which we get to collective decisions, and we encourage and support participation and endorsement support for group collective decision-making through law and politics. Now, again, I don't want to sound like there's no problems in the world. Of course, there's lots and lots of failures and inequalities in these processes, but nonetheless, the evolution of human societies to the pretty phenomenally complex worlds that we have today are partly being aligned through law and politics. So we know that those perfect markets don't really exist, for example. So we have to use legal rules to structure those markets. There's a whole bunch of assumptions in the theorems about perfect markets that are assuming we have legal rules of contract and property and your entitlement to a trade, and we can enforce our trades over time. And then we also use the legal rules to correct market failures, to sort of subsidize where we need to subsidize, to require information disclosures. We have rules against, banding together to set prices or engaging in fraud in markets. And then also that redistribution doesn't happen in the abstract with redistribution of endowments per se, but rather with redistribution of resources and the outputs of markets. We also have a lot of alignment that's happening in the way our organizations work. So our organizations inside our firms and our universities and our nonprofits, organizations are also making allocation decisions about what to produce and how to price it and where to send it in the absence of those market prices. So internally making those decisions, which you can think of as a visible hand. And of course, our legal and political institutions are constantly making decisions about what is the social welfare function, right? We defined it in that economic theory as a sum of individual utilities, but we are not bound to that as the definition of what we mean by social welfare. We use these institutions. So I want to think about these things as alignment mechanisms. Now, I spent most of my career thinking about the design of legal institutions, regulatory institutions, how well our markets for law and legal production work, and published a book in 2016 that looked at the ways in which our production systems of law and regulation had kind of fallen out of step with technology, globalization, and so on. And so that's what I've spent a lot of my career thinking about. But that same year, 2016, is when my son and now co-author Dylan Hadfield-Manel showed me this video out of OpenAI, and I started to think about questions of alignment in AI. Now, he also at the same time started talking to me about a problem he was working on as a grad student about the challenge of figuring out how to establish the rewards for a reinforcement learning system, a robot. And so we're saying, well, there's this problem of the computer, the designer of that system can only operate on the basis of what they think is important in the world and what rewards they're looking for. So think about that boat going in circles. So they write down what is a proxy reward function, but it doesn't necessarily capture the true reward function. So in this environment, the designer is just thinking about how do I train this robot to get efficiently from where it starts to the pot of gold, and hasn't anticipated that the environment at deployment will include something totally unexpected like lava. And there is actually a reward associated with lava, and that's excluded from the reward. And the thing that happened when we started having those conversations, I say, well, this is very much like what I was thinking about as a graduate student in economics. I was thinking about contract design is complicated by what kinds of rewards we're able to write down. I was thinking about the much less interesting question about franchising, and the idea that we have a franchisor who has interests in how well the franchise is working. We have a franchisee who purchases the franchise and operates the franchise and has a different set of rewards. And the challenge for the franchisor is how to establish the incentives for that franchisee so as to promote the interests of the principal, the franchisor. And the context in which economists had primarily been thinking about this problem was what we call the complete contingent contract, the idea that you write down everything you care about and you attach incentives to it, payoffs for the franchisee to get to an outcome. But what was happening when I was a grad student is people were starting to come to grips with the fact that, oh, actually, contracts are incomplete. We can't write down, it can be very hard to write down the incentives associated with, say, the effort of the franchisee. It's hard to measure, you can't get a good metric for it, hard to write down those payoffs. And so the challenge became, how can you secure the best possible set of incentives in the context of an incomplete contract, and recognizing that this required appeal to the institutions outside of the contract. So either formal legal institutions or informal institutions like reputation, which I've got as a little symbol here of social enforcement. One of the key mechanisms we use for social enforcement of our rules is exclusion. So that's what that little figure is to represent. So what Dylan and I did after sort of discovering this convergence in the kinds of problems we were looking at, we wrote this first paper on incomplete contracts and AI alignment, which basically just went through the fairly established literature, decades of literature in economics about the problem of incomplete contracting. Why are contracts incomplete? Why don't they say everything we want them to say? And said, we can look at analogs directly relevant to the design, the writing, the specification of rewards in reinforcement learning systems. And we illustrated this, I think, in a way that is still quite helpful as a visualization of what we're thinking about. So around the same time, Dario Amodei and others had published a paper called Concrete Problems in AI Safety, which I'm sure many of you know, sort of posing, here are the problems we're trying to solve in AI safety and alignment. If you have you have a robot, you write down a reward function to train the robot to learn to carry boxes efficiently from one side of the room to the other. And they say, oh, but at deployment time, something you didn't anticipate, expensive vase shows up on the optimal path. What is the robot going to do? Well, the robot is going to go straight through and smash the vase because there's nothing in the reward function that says that there's a cost associated with smashing that vase. So we thought about, well, okay, let's think about the analogous situation where you hire a human to carry boxes, and the human is given the same reward structure, the same contract of a buck a box that you get to the other side of the room. Employer writes that contract, leaves the employee to their job. A vase appears in the path one day for the employee. What's that human employee going to do? Well, we all know the human is going to walk around the vase. And the question is, how does that happen? And the key insight here is to recognize that what gets the human agent to make the adjustment that we would like our robot to be able to make is that human contracts are not actually written inside a box. They're written in a way that relies on a lot of normative infrastructure. So the human engages in a thought process, seeing that vase there, and says, oh, if I follow on my usual path, I'm going to break that vase. What might happen then? Oh, well, there may be legal consequences. I might get sued for damages. My employer might be authorized to withhold the cost of the broken vase from my wages. I may get a bad reputation, right? I mean, legal consequences, but the employer gives me a bad reference, or my coworkers think I'm a bit of a jerk and don't help me get the next job. But that the contract is basically getting filled in. Oh, there is a cost associated with knocking over that vase. And this human agent is able to access that because there's this normative infrastructure and because there's this capacity to think that through. So what we're trying to do, we'll spend a lot more time talking about this is at this tutorial in NeurIPS if you're interested. Say we really want to think about reframing the alignment challenge to how do you build the normative infrastructure for AI systems and agents? And how do we build what I call normatively competent AI systems and agents that are able to interpret and participate in those human normative systems? So when that human agent is imagining, oh, here's what will, if I keep going, here's what will happen if I stay on my path, I'll knock over that vase. Oh, now I need to think about what those institutions are. That's what I mean by normative competence, the capacity to think those through. There's other things in normative competence, but that's in that setting there. So I've been thinking theoretically and using sort of economic modeling to build a theory of normative systems for the last 12 years or so with my colleague Barry Weingass from Stanford. And so I want to give you a couple of, I want to define some terms since we throw this language around a lot. So we define normativity as the human, maybe we want to figure out how to extend it to machines, but the human practice of classifying behaviors as appropriate or not appropriate, and then channeling behaviors to appropriate. You can substitute for appropriate, okay, not okay, punishable, not punishable, moral, immoral, good, bad. Just want to say we're trying to build a parsimonious model. I want to take as much of the phenomena that we're trying to explain out of my starting point. So I just want to say binary classification system. This is an okay thing to do. That's not an okay thing to do. And then the way we think about the way human societies are structured is that they contain a critical form of institution or multiple institutions. We call these classification institutions. So these are the mechanisms, and they could be defined entities that perform that classification. This is okay, this is not okay. And in early human societies, in sort of those small hunter-gatherer bands, they could be just entirely emergent. The classification institution might be entirely emergent. It simply emerges from the conversations, the criticisms, the talking around the fire and under the tree about this is an okay behavior. Oh, did you see what that person did? Oh, but that's okay. That's not okay. Eventually, we know that settles down into a pattern because we know from our ethnographies, we can go look at those societies and say it's very clear what they think is okay and not okay collectively in this group, even if there's not a distinct institution. But what we see as human societies grow in complexity and size is that they start to establish explicit institutions for classification. So we might see the emergence of the elders. And I'm doing some work with Sarah Matthew from Arizona State University right now, looking at the institution of elders among the Turkana, who are a pastoral community in Kenya. What's the structure of that institution for resolving the question of was this okay or not okay? We get the religious leaders, we could have dictators, monarchs, legislatures, courts, lawyers, all the way sort of taking us into our complex systems today. That's sort of an increasing level of formality. That classification institution is paired with a mechanism for enforcing those classifications or getting to an outcome where those classifications are actually implemented. People are mostly doing what's okay and not doing what's classified as not okay. We focus on these third-party enforcement mechanisms, ranging from sort of very informal and quite mild mechanisms for expressing disapproval, making fun of someone, criticizing, escalating to things like exclusion and ostracism. We then can get more structured systems of, that there's authorized retaliation against somebody who's chosen the not appropriate behaviors, into formal systems of fines and incarceration that we see in our advanced systems. But all of these are about third-party enforcement. We define a normative social order as then the equilibrium that's secured when we manage to coordinate and incentivize third parties, bystanders, basically, to engage in that punishment of the behaviors that are classified as punishable. And so what we focus on is that challenge of saying, normally when we think about normativity and trying to get everybody to follow the rules, we think about compliance. And we don't focus on, well, how do you actually get the community to enforce collectively around a shared set of classifications? And the paper that's cited at the bottom of this slide here, the What is Law paper, presents a formal model that sort of looks at that as the core problem to solve. How do you incentivize and coordinate? We then define normative infrastructure as institutions, behaviors, and cognitive architectures that support that normative social order. And we think about humans as having evolved to be normatively competent in the sense that they recognize and interpret classification institutions and then participate in and respond to enforcement mechanisms. But the participate in is really quite central, because if you've solved the problem of coordinating your group to criticize, potentially exclude from the benefits of the group, a person who has chosen a behavior that's classified by the classification institution as not appropriate, if you solve that problem, then your compliance problem, that's how you solve your compliance problem, right? So you've coordinated that punishment scheme. So if we reframe this alignment challenge as how do we build normative infrastructure and normatively competent AI systems, what does that research agenda look like? So let me talk about some of the directions we've gone in this work. So one of the things that once you start focusing on this question of how do you secure that equilibrium in enforcement behaviors and punishment behaviors, that's the secret to your stable group. That's the secret to implementing a classification institution, which then gives you the opportunity to develop better rules, better classifications that can improve the performance of your group. Doesn't have to go in that direction, of course. There's a very famous paper by Rob Boyd and Pete Richardson on how coordinating third-party punishment can get cooperation to evolve for in human societies, but it can also get anything else to evolve in human societies as well. If you've coordinated your group, you can kind of get anything out of the behavior in that group if you've coordinated on collective punishment. And one of the things that thinking about this does is help you say, okay, so now let's think about, rather than focusing on the individual norms or rules that a society has, which most of our theories of normative systems tend to focus on why this norm solves this kind of a game theoretic problem, or might be adopted because people have these kinds of preferences. If you start thinking structurally like this, you can start to focus on things. Okay, so let's think about what the entire set of rules in that classification scheme, what does that look like? And how does that influence the stability and the capacity to secure an equilibrium? So this set us off on a path of thinking about a distinction here between what we called important rules and silly rules. Now, important rules we defined as rules that prescribe behavior that has a direct impact on welfare. So these are the kinds of stories we normally tell about rules, that, oh, the reason we have this rule is because it solves a coordination problem, or because it encourages people to invest. And so these are rules like keep your promises, leave others' property alone, don't sell cars without seat belts, and during a pandemic, wear your mask. Those are ones we can say that rule, we can see the direct impact on welfare. But we also defined something that we called a silly rule, rules prescribing behavior that has no direct impact on welfare. And our societies, every single human society, is chock-a-block with rules like this. I mean, these are rules of etiquette, these are rules of clothing, these are rules like how far apart do you stand when you're talking to somebody? Do you shake someone's hand? Do you pat them on the back? And so here's some examples of things that you can that would fit this classification. But I want to emphasize every society has lots and lots of silly rules, and we actually worked on why is that the case. They're not just hangovers and not just blips or errors. There is something functional happening, and here's how we thought about this. So we first paper we did, we looked at a computational experiment with agents that were sort of POM-DPs that were making choices about whether or not to stay in a group. They're all assigned into a group to start with, and they have to they engage in a repeated sequence of interactions with 3 agent interactions. Each one is drawn. There's randomly, there's an entity. One of the agents is defined as the victim. One agent is defined as the scofflaw that'll potentially violate a rule. And then there's a third party agent, bystander agent. So we have these 3-person, 3-agent interactions. And each interaction is then governed by a rule drawn from the set of rules that defines that group. And in each interaction, the agents have to decide, will I stay in this group, or will I go off to my safe payoff, go to my island to get my safe payoff, or will I stay in the group? They have to decide from each interaction. And the way the payoffs are structured, there is an important rule. We don't give it any content. It's just that there is an important rule that will produce a higher payoff for agents if they stay in the group, provided there are enough agents around willing to punish violations of that rule. So that's like, we have a rule that says, you have property and you can anticipate it won't be taken, but there have to be enough agents in the group who are willing to punish a violation of that rule. And so even though I'm not a big fan of just putting these into types, that there's punisher types and not punisher types, that's what we did in this paper. And what we then did was we varied across all of these different groups the density of silly rules as a fraction of all the rules. So there's the same important rule in all these groups. It's just that some only have the important rule, so they have a density 0 here. Those are the orange dots on the screen. Up to groups that have 90% of the rules are silly rules that have no material payoff. It doesn't really matter whether the rule is violated or not. There's not going to be a cost. It's only a cost if the important rule is violated. And what we were able to show with this paper was that the societies, the groups that had high density of silly rules, as long as they were inexpensive enough, right? They can't be super costly, but they have to be inexpensive enough. Those societies were able to maintain their group membership better than the ones with just the important rule. Even though if I asked you before we started, would you rather live in the society with a whole bunch of silly rules or just the important ones? Most of us would say just the important ones. We say, well, that's actually not going to be a stable society. What's on the vertical axis here is the proportion of the communities that are active after a certain number of community interactions shown on the x-axis, and the size of the the ball here is the size of the population. So what we were able to show was that a lot of low-cost silly rules can improve the stability of your group. And the reason is that through those silly rule interactions, you get observations on how many punishers are around here. Do we still have enough punishers in our group? And we were looking at a setting with a shock where all of a sudden there's a bunch of newcomers and you're not quite sure who's a punisher or not. So we sort of thought, okay, so if we're going to start thinking about AI, we wouldn't want to just think about important rules. Maybe in order to participate in our stable systems, we need to understand and participate in silly rule enforcement. The next paper that we worked on in this area, thinking again about silly rules, looked at a multi-agent reinforcement learning setting where we were interested in the impact of silly rules in an environment on the capacity for these moral agents to learn what we call normative behaviors, enforcement and compliance of the rules. So this was, it was what we called a poison berry environment. It was just a grid world with lots of different colored berries in it. One of the berries colors, one of the colored berries was a poisonous berry, which would have a long delayed impact on the health of the agent if they ate it. And we implemented rules or taboos in this environment by if an agent ate a taboo berry, they became marked. They changed colors. And so the other agents could see that they had changed colors. And then all of our agents, this was building on some work about social dilemmas coming out of DeepMind, starting in about 2017. And this was in collaboration with folks at DeepMind. Each of the agents had the capacity to zap the other agents and impose a cost on the other agents. That's the yellow beam here. So that's a punishment action. So even though it looks like it's a physical thing, it could also be that you just tell somebody off. If you want to think, sometimes when we talk about punishment schemes, everybody's thinking of very aggressive things, but in fact, we're engaging in third-party punishment all the time when you tell somebody off or give them a dirty look or gossip about them to someone else. So this is how we represented enforcement. And then we looked at 3 different conditions. So we trained our agents in 3 different environments. In one, there were no rules, no taboos. There were poison berries. Agents could just get rewards for eating berries, and they could punish other agents for whatever they did. We looked at a condition where there was an important rule, which was to say that the poison berry was made taboo so that agents would get rewarded if they punished an agent that ate a taboo berry. And again, they could tell who'd eaten a taboo berry because the agents turned color. And then we looked at an environment that had the important rule, poison berries were taboo, but also a harmless berry was taboo. So that's a silly rule. There's no reason to have it or not. It doesn't really matter if anybody violates it, no impact on welfare. And we looked at performance in these 3 different environments. We wanted to know, will the agents learn to punish? Do they learn to avoid punishment? Do we get a stable state with normative infrastructure? Because that's what we've built here. How does the presence of a silly rule affect learning? And does that normative infrastructure raise payoffs? The introduction of there's a rule, there's rewards for punishing according to the rule, and there's a punishment technology. And so our results demonstrated that, and if you just want to take a look at the last panel on the bottom, panel F, the collective return panel, yellow is the environment with no rules at all. Red is the environment with just the important rule. Poison berry is taboo, and the green lines are showing us the silly rule and important rule environment. And what you can see is, number 1, the agents without any rules don't learn to avoid the poison berry. It just the impact, the delay on health is so long, it's a credit assignment problem they can't solve. They do learn to avoid the berry, and they get higher collective reward with the important rule, but they do even better over a significant period with the silly rule. And what's going on here, and we can see it probably a little clearer in this diagram here, is that the green societies here are the important, and the silly rule, the red, are just the important rule. And what you can see is that the groups with the groups of agents with the silly rule as well as the important rule, they engage in lots more punishing. Punishing is on the vertical axis in early stages. And then they spend a lot less time, that's what's on the horizontal axis, in later stages. So that the agents are learning first to punish and collecting those rewards for doing the socially valuable thing. So we've just written that straight into the rewards to do that socially valuable thing. And then once the agents have learned to punish, then we get compliance, then we get avoiding the berries. And even though there's more punishing happening, there's more taboo berries, collectively they're doing better. So what we're seeing from this work is that normative behaviors are supporting better choices, and the silly rules, right? These things that are actually hard to predict and explain, when they are in that rule set, they are supporting the learning of normative behaviors. So again, a basis for thinking. We need to think about rule sets and think about alignment here. This is obviously a very simple version of alignment. It's just, we didn't even compute the benefits to the group of having fewer sick people around. And we just emphasize that this approach of thinking about the normative infrastructure gets you to insights here that you're not going to get from thinking about sort of a game theoretic, how do we solve this problem, which is sort of a standard methodology. So then we start exploring this question of, can a normative institution help agents learn those normative behaviors? So we had agents in that paper I just showed you that learned normative behaviors. There was a hidden normative infrastructure that we as experimenters had just encoded into the reward structure. And now we're going to look at some work that says, okay, what about if we had explicit normative institutions? So that think about that employee agent and the boxes being able to imagine, oh, let me think, maybe I could even go consult what the legal rules are around the implications of breaking a vase, or I can talk to my friends and find out, what would you think of me if I knocked over that vase? Can a normative institution help with that? So this is continuing work, continue to revise on this project. This is, again, in a multi-agent reinforcement learning context. We're looking here at a commons harvest problem. So thinking about the tragedy of the commons, where you can deplete a resource if you overconsume it. We have a setting where we have 7 agents that are collecting apples from 6 different patches. They get rewarded for eating apples, and apples regenerate as a function of the number of apples in their immediate neighborhood. So if we eat too many, they can be depleted and they stop growing for that episode. We also gave these agents the capacity to punish. So in the same ways we just saw in the silly rules paper, they can punish other agents. Punishing is costly to the agents. They incur a cost of -10 when they punish another agent. It's costly to be punished. If you get zapped, punishment of -10. But again, we've implemented the idea of rewards for punishing agents. They receive a +20, so a net +10, if they are punishing agents harvesting from a patch that has been in this community classified as inappropriate, wrongful, violates the rules, don't pick from that patch. And what we looked at here is we compared 2 environments. One was the sort of like the original environment where we have the hidden rewards for this punishment. So same as that silly rule setup. That was a hidden rule context where the agent just had to discover through their punishment trial and error, oh, there's a reward if I punish in these ways. So here we've got, in the original environment, or the baseline environment, we've got the rewards that system that I just told you about is hidden. And then we in a second environment that we called the altered environment, we introduced something we designated as an altar, as in a sacred place, a common space, a place where we look to for the authority of what the rules are in our society. We introduced this thing that we're calling an altar. It's a normative institution. And the only thing that's happening with the altar here is that it has a color. It has a color on it that represents the state of the rule for where it's okay to pick your apples from. So we've got, but we have in both of these cases, they have exactly the same classification and reward structure, and it's dynamic. So let me just say a little bit more about this. So we're going to designate those top zones as the red zone, the middle is the blue, the bottom ones are the green zone. Our alter in the first one is saying, okay, the color on the altar is blue. That means it's okay to eat from the blue. That means that there will be rewards for punishing an agent that eats from the red or the green. That designation, which and both things are happening, but at the same time, in the same way, with the same dynamics in the baseline case and in the alter case. That the rule on the altar, the rule in the reward structure is changing based on the depletion of those apples based on what agents are. So you can see this is an effort to say, you can't collect lobsters during this season, or, deer hunting season doesn't open until this date, or we're not fishing from this part of the from this lake right now. And what we're able to do in comparing these two environments is see that the agents do much better at maintaining the sustainability of their crop, the harvest, and they achieve higher adjusted rewards here when there's an alter as opposed to when there is not. So the purple line here is the alter environment, and the yellow is the hidden rule. They get significantly higher rewards. They have much lower depletion of the resource when they're able to implement this rule. Now, remember, this rule is not something that's encoded for them. It's something that they learn from learning what the rewards are for punishing and that's a dynamic that's changing over time. So the alter is helping the agents learn better, what's our rule today? What is it that I should be punishing? And that's because you're changing that in punishment behavior, you're changing the harvesting behavior. The agent, in the presence of the alter, the agents are able to correctly sanction. So sanction the correct behavior, which is, if blue is on the alter, it's like, okay, punish somebody who's picking red or green, and decreases in the number of incorrect sanctions. And this is an important observation, and I'll be finishing up here. Importantly, what we saw is that the agents learn to visit that alter, basically consult the alter on a continuing basis. And I think the way you want to think about this is that the alter, which is just a square with a color on it, that's all it is. What the alter is doing, it's the same thing for these agents that it does for us as humans. It is making it easier. It's reducing sort of the computational load, the difficulty of figuring out what are the rules and then coordinating those agents to punish the behaviors that then improve the payoffs for the group. Where we'd like to go with this is to see whether or not we can get generalization from this. So if we train the agents to learn about alters in one environment, are we able to then, as long as we put an alter in a very different kind of environment, will our agents trained in the one do better at more quickly getting to align behavior in the second? So if you go back to this picture here, this is what we're trying to develop. It's like, can we train our AI systems, our AI agents to respond to that infrastructure? So I'm just going to close here with my favorite definition of artificial intelligence. It's about intelligence is a quality that enables an entity to function appropriately and with foresight in its environment. It's the use of that term appropriately to say, actually, thinking about normative competence and normative institutions is fundamental to intelligence. So I'm going to stop there. Why don't I stop the share and then we can see each other.
Great. Thank you so much, Jillian. It's really a pleasure to hear from someone who's fluent in both kind of the technical side and also the legal side or even the economic side of how to think about these things. Um, I wanted to ask kind of a hefty question, but I would venture as far as to say that at the current moment, users and developers are kind of aligned with each other in terms of wanting AI to be better and easier to control. But I do wonder what you think about whether these goals will diverge in the future, and along those lines, how you think a normative infrastructure, or I think you mentioned also this equilibrium, like a normative social order, can be formed between parties that may have different goals or different, either concrete objectives or soft ideas about what is good or what is bad.
Right. So that's actually, it's a critical observation to recognize that the challenge of normative social order is precisely the challenge of coordinating people, agents, entities that have different interests, that have different goals, that could have different ideas about what is good and what is bad. But so take that as just the state of play. That is just the description of what it means to have a group of people. And so we look at those. Say, let's go back to our so our ethnographies of hunter-gatherer groups, and we say, oh, but they're so homogeneous. Like everybody dresses the same, and everybody eats the same foods, and everybody has the same set of norms about what's appropriate behavior. And say, but that's what the equilibrium they were able to achieve, not an innate description of the members of that group. Think now about our complex, think about that economics theory about alignment and markets as alignment mechanisms, right? The starting point there is everybody has their own idiosyncratic, totally self-interested idea about what they value. And we could have, those utility functions include moral values and, preferences over what other people do. And so it could be that we would have a lot of conflict. Certainly in the principal agent setting, that, the franchisor and the franchisee, that's the fundamental problem, conflict of interest. And so the challenge of normative social order is how we do that. So I actually think the question of, well, will developers and users have divergent interests is, yes, of course, that's the endemic nature of societies. And that's why there's a challenge of how do we resolve that? So I think that, when we're thinking about alignment, we precisely, and that's why I think it helps think about alignment to the group and not just alignment. There'll be a lot of alignment that'll happen between developers and users because developers are trying to sell because it's in a market, right? But that's where we say, oh, but actually there's externalities from some of those behaviors. Or we might think that there should be collective decision making about you shouldn't let your agent do that. Or there's going to be these interactions that will destabilize our markets or whatever. And so we have those collective decision making. So I think it's a really, really important insight of this is to say, that's the problem we're trying to solve. Conflict of interest, divergent interests. How do we build the infrastructure that supports actually all start, mostly moving in the same direction?
Thank you so much. And also zooming out to some actual norms, policy, and regulations. I think a theme that we've recently seen a lot is that policy generally develops more slowly than technology. So while we're spending time to think about these infrastructure that you're mentioning, how do we optimize it, making sure that things are all moving the same direction? So how do you approach actually building out these policies or ideas for policies so that they're still relevant and meaningful by the time they're actually implemented?
Yeah. So one of the I think where I am on thinking about AI policy is from this perspective of saying we know we're going to need normative infrastructure and normative competence in our AI systems. That's the only way we will be able to govern them. And so instead of thinking about, I mean, we should be thinking about what rules do we want, like, you know, we don't want them to be able to build weapons or help people build weapons, or we don't want them to use toxic speech and so on. I think actually a lot of our policy work right now should be, how do we build this normative infrastructure, the normative institutions that are capable of then responding and evolving to the types of behaviors we start to see from our AI systems. And I think that, you know, if you come to this with this lens of saying, the way humans solve the alignment problem and the way we've evolved our solutions to the alignment problem over millennia has been, we build institutions, those institutions evolve, they become better at responding to change, because it's really amazing. You look at how human societies have changed and done that. And I think what we don't want to do is just say, well, we have a fixed set of institutions. That first paper that had the title of What is Law on the theory side, it was really to sort of make the claim, don't make the mistake of thinking that law is our existing set of institutions, right? Actually, our existing set of institutions are like a couple of 100 years old. Think about the fundamental problem you're trying to solve with this, which is this problem of normative social order. So that's what we were trying to do, was, as I say, to sort of build this parsimonious but powerful framework, classification institutions, incentivizing and coordinating third-party punishment. Think about that as the challenge. So I think that's actually where I would be focused on policy right now. I think there's a lot we could be doing on that score.
Got it, got it. Yeah, that's such a very enlightening idea to think about this whole systems rather than specific policies and rules, which I think most of us are more concerned with from a day-to-day basis. So yeah,
Yeah.
thank you. Yeah, I think we're near the end of our time for today. So again, thank you so much for coming on to the past seminar today. It's really an honor to hear from you and all your disciplinary thoughts. And I hope you had a good time with us today, and hope to see you around again soon.
Great. Thanks so much for inviting me. I've really enjoyed it.